All right, and so Ted, in this lesson here, or this video here, we're going to be taking a look at how do we use technology to find some of our statistics. So far what we've done is we've looked at mean, median, mode, as well as standard deviation, and how we can use regular math and formulas to try to solve for those. The problem is, what happens if we have a very large group of numbers? A very large group of numbers, it's possible to find the mean. Takes a little bit of time to calculate. It's possible to find the median. Got to make sure we organize them from smallest to biggest and make no mistakes. The mode, yeah, it can be possible. Standard deviation, difficult, very difficult. So trying to come up with our with the standard deviation by hand can be extremely difficult. In front of you in this little document here in the notes is a program that I have used in the past that deals with standard deviation, a bunch of other data. We are not going to use this one. Apologies, it's in the notes, but we're actually not going to use it, as I've had some complications in the past, so I've tried to make something a little bit simpler. What we're actually going to use is a calculating statistics sheet. It's a very simple Google sheet, which I have created so that you can calculate a large set of data really quickly. Now, this sheet here is available to you in Google Classroom and as well as Google Drive in the folder. And so you can load it up and use it as well. Make sure though, if you do take it, you can't actually modify it because it's view only. You'll have to create a copy of it yourself so that you can use it for any of your assignments. Now I'm going to take a look at how do we use this sheet and how does it give us the information that we need. So here's an example that we're going to be taking a look at. Brendan works part-time in the canteen at his local community center, and one of the tasks that he has is to unload delivery trucks. He wonders about the accuracy of the mass measurements given on 2 cartons that contain sunflower seeds. Now, if you look at a package of sunflower seeds or chips or really anything that's packaged, it'll often say a mass on there. Now, are those masses accurate? Well, we kind of assume they are, but in fact, they're not. There's always some variability in how accurate those numbers are. So here, Brendan decided he was going to measure 20 bags of both a 227 gram bag, or at least what it says is 227 grams, and a 454 gram bag. So in the 227 gram bag carton, the 20 bags you'll notice have a bunch of different masses. There is a low of 218 and a high of 236. I believe here is our high. Yeah. So there's a low and a high, which means that there is not actually a set amount in there, but it's pretty close. And really what it is that 227 grams is actually the normal based on a large grouping of data. And we'll talk about kind of where certain things fit in a little bit later on. Now, what we want to do is we want to figure out, is this carton actually, do they average out to 227? And we're going to find our different measures of central tendency. So I'm going to go over to my sheet here that I have. And on the left-hand side right here, this column, not including 1, is going to be all of the data points that we have. So I'm going to put in the data points. Now, I have them on a different sheet, so I'm not having to go back and forth, which is really nice. Here we go. Okay, so there's my 20 data points that I have on the 227 gram packages. On the right here is all of our data that we're going to have. So I have a count on there, so how many are in that grouping, and you'll notice that there are 20, which is good. That's what we should have, okay, because we had 20 in the original. The mean is 227.15. The median is 227.5. The mode is 227. And then we have our standard deviation of 5.23. So this is the calculated standard deviation. Instead of you having to go through it and do it by hand, I've given you the answer just like that. Now, I also have the smallest and largest on there. The range is how far in between the smallest and the largest value. That can be helpful at times too. We won't really need it a whole lot, but it is there and we can use it. So let's put those values down there. So we're going to create a some data here. So the 227 gram bag, mean equals 227.15 grams. The median is equal to 227.5 grams. You can get this kind of lined up a little bit. The mode is 227 grams. And our standard deviation, I'm just going to get my little symbol in here, little sigma, is equal to 5.23. Okay. So now remember that sigma represents how consistent it is. And so it's actually the average distance each value is away from our mean. Okay, so it's the average distance that each one is away from our mean. So on average, you would get a bag that was either 5.23 less than the mean or 5.23 bigger than the mean. So on average, you should get, so that's kind of what that represents. Okay, so that's the 227 gram bags. And now let's do the same thing, but for the 454 gram bags. So 454 gram bag, mean, wait a minute, we need to solve for that first. All right. Okay, so we've done that. Now, when you are doing this for an assignment, what I would like you to do is to take a screenshot of the work that you've done, and you can put it into a Google Doc. You don't need to put it on Cami. Put it into a Google Doc and send that to me as well with what value it is. You can write in, okay, this is question number 2 or whatever the case. But send me a screenshot of this so I can see where you got your values from and if you've kind of put everything in the way that I think it should be in, or the way that or the correct way that it should be in. All right, let's do the next one here. So 458, 445, 457. And there we go. Did I get that all? Looks like same answers that I got. Okay, perfect. All right, so here's our values for the 454. We have a mean of 454.4, a median of 455, mode of 455, standard deviation of 4.5, and then we have smallest, largest, and our range is actually exactly the same. So the mean that he found was 454.4 grams. The median was 455 grams. Let's do the mode was 227. Oh, sorry, I just copied the mode there. There we go. And we'll do sigma again. That's 4.5, and we can do 4.50, 2 decimal places. All right, so now how can the measures of dispersion be used to determine the accuracy of measurement is the same for both bags? Well, standard deviation tells us how accurate or how sparse these data points are. The smaller the standard deviation, the closer to the normal or the mean are the majority of the bags. So the smaller the standard deviation, the more accurate is the measurement. Okay, or the more accurate is the data. So if we look at standard deviation, in the first one here, it's 5.23, and in the second one, it's 4.5. Now, what that tells us, the number is kind of arbitrary, really, but it tells us that our 454 gram bags are actually packed more accurately than the 227 gram bags. Okay? And in fact, if we look at the mean, if we get a 227 gram bag, on average, we'll get 0.15 grams more. In a 454, on average, we're actually going to get 0.4 grams more. So we're actually going to get almost over twice as much extra seeds in those cases there. So, but back to what we were going through here. How can measure dispersion? Well, the 454 gram bags are more consistent in their packaging as the standard deviation is lower than the 227 gram bags. Okay, so really it's all about that standard deviation. Is the standard deviation small or big in comparison to the other one? Okay, now really this is a comparison tool. It's not so much a data collecting tool, it's a comparison tool between two or more different groups. Okay. Now, what the standard deviation tells us is that there is an expected range, and we'll talk about how that standard deviation affects that expected range. But yeah, and we'll get into that a little bit later. But it kind of gives us an idea of where, if we were to get a bag of this, where would we expect, or what percentage of a chance would we have that we would get a bag in a certain range?